You guys, we have the 1 over 1 minus x. Remember what that was? Yeah, 1 plus x squared plus x cubed, etc.
I heard from another teacher that we're 6 plus x.
No, we're not. I don't know who you heard that from. We're right on schedule. You can find other power series. Now, it's a power series because, Grant, it's a series, which means you add up the terms, made up of powers. And you can find other power series by integrating this, differentiating this, multiplying by x, and there's a lot of ways you can find relatives to the geometric one. But what if it's not geometric? And in your project, you should have found that a power series that will always generate a power series, a formula, is t of x is a Taylor polynomial. And it's f of a. Now, I'm going to write it out the way I can remember it because there's patterns here. That it's x minus a to the 0 over 0 factorial. Okay? That, yeah, degrees, factorial. Then it's plus f prime of a, x minus a to the first over 1 factorial. So this is the 0 derivative. You're not taking a derivative. Plus, then it's the second derivative. Yes, we do. And it's focused on this chapter.
This chapter, why this?
Because this is the BC. Oh, no, we've been doing this as all quarter. Plus f triple prime of a, sorry, x minus a cubed. No. Okay, what? The final will be partly multiple choice, and there'll be a couple free response questions. Plus, what's the nth term? It's the nth derivative. And then it's x minus a to the nth over n factorial. That's the Taylor polynomial. Okay, guys, I'm not going to teach the error to this because the error is, you won't remember it in April and May anyway, so there's no reason to teach the error. Okay, now, you can see you're not real concerned. What did you guys do here? Yeah, that's pretty, I don't know, but it wasn't here at the end of class today. I don't know, I'm blaming it on somebody. Okay, it's wrecking my board, which is a very, very expensive machine. Okay, if A is 0, it's called a Maclaurin series. You hope to get a Maclaurin series. So it's f of 0, x minus 0 to the 0 over 0 factorial. Okay, guys, plus f prime of 0. You don't have this stuff down, you're not going to get the 5 on the BC. Not going to happen. This is the majority of the exam. It's x squared, x to the first over 1 factorial plus f double prime of 0 over x squared over 2 factorial plus f triple prime of 0, x cubed over 3 factorial. See the pattern? And it's the nth derivative at 0, x to the n over n factorial. Okay, did you guys do e to the x?
E to the x is 1 plus x.
You will want to memorize this one. Okay, Ori, what's e to the x? Centered at the origin. This is the Maclaurin series. Okay, you want to memorize this. Good. Do you guys know how to generate it? Well, you should have done it. It's not hard. This is the very first day. You had plenty of time. Yes, you did. You had a video. And you guys take some responsibility. You know, you did a project on this. Unless you copied it off the web, you should know how to do it. Yeah. Yes. And so the formula is right up here. It's f of 0. Hey, guys, do you need to get someplace else? Ori? I need you guys to pay attention. This is not that hard. It's the derivative of the function at 0 times x to the 0, or the whatever derivative it is, whatever term it is, over that number factorial. So I have to do e to the x, then I have to do its derivative, which is what? E to the x, and its derivative, which is e to the x. Well, it's not real tough. What's f of 0? It's e to the 0, which is 1. What's f prime of 0, Ori? This is f prime, this is f double prime. So it's 1. Don't assume. What's e to the 0? It's 1, not an assumption. It is what it is. What's f double prime of 0? I'm not assuming anything. It's e to the 0, which is 1. So you just substitute it into this formula. So for the Maclaurin series, e to the x is equal to f of 0, which is 1. 0 factorial is 1, and it's x to the 0, which is 1. That's why that's just 1. It's just a formula. That's all it is. Plus the first derivative at 0, which is 1, x over 1 factorial. And it's the second derivative at 0, which is 1, x squared over 2 factorial. That's all there is. So it's x to the n over n factorial. Yes, you have to know this. The ratio of convergence, you have to guess what you have to do to find that. The ratio test. And I believe this one converges for everything, but should we do it? Okay. So let's go. Remember the ratio test. You are going to be asked this, and it's usually 5 to 6 points. So it's easy. It's the limit. Do not forget the absolute value. Okay, that has to be less than 1 as n goes to infinity. That's what my goal is. Then you'll have to check your endpoints too. No, but it better show, if you really want your full points, I would write it. I had to guess sometimes to see if that's what they want, if they were trying to say. Okay, Grant, what is this going to be then? Now I take the nth term, which you have to be able to do, or you can help them. So it's x to the n plus 1 over n plus 1 factorial. And then we're going to take this and flip it. So it's n factorial over x to the n. Okay? And we should be okay with this. That's review. Only thing that we didn't do was apply the Taylor polynomial. That was it. And so we're going to do AP problems after I get through these lessons here. So this is the limit as n goes to infinity. I like to write this as x to the n times x. N factorial, and x to the n I'm going to put over here. And n plus 1 factorial is n plus 1, n factorial, less than 1. These cancel. Let's see, those cancel, and I get the limit as n goes to infinity of the absolute value of x over n plus 1 less than 1. What is that limit? That's 0. No matter what you put in for x, this is always 0. So guess where this converges? Everywhere. Remember, there are 3 places, 3 ways things can converge. At a point, and that would be at the center of the interval. Remember, we centered it. At a point, it could be on an interval, A to B. I have to check the endpoints, or it could be everywhere. And this is everywhere. So the interval of convergence is minus infinity to infinity. That's it. Because that limit is always less than 1. Yes. Okay, Grant? I'm sorry, what's that? It converges everywhere. Nope, it's either going to be at a point, at an interval, or everywhere. One of 3 things. Okay, so you should be taking some notes. Do you need a sheet of paper, Ori? Not a problem if I get the right one. Okay. Going on. Let's see. Find the Taylor series, for example, but let's center it at A. So that's going to be harder. And you need to know the sign of x. Okay. So f of x is equal to e to the x. Now, pay you guys, sometimes they ask you to do the Taylor polynomial like this, Nick. Sometimes they don't. Sometimes they give it to you, and then they'll ask you questions about it. Okay, Drew? So I'm going to work this out, and I can. There was the one of sine of 5x plus pi over 4. It was not very fun, but it was a regular problem. What's f prime of x? E to the x. F double prime of x, e to the x. No, no, give it to me. Not going to put up with it. Okay, you should have this yellow sheet out. Do you need one? Okay, do this one. Good. Good. How do I do this? Centered at A. So it's going to be f of A plus f prime of A. Do you want me to put all the other stuff in there? And it's x minus A over 1 factorial. And the more you do it, the more better you're going to be at it. What's the next one? F double prime of A, x minus A squared over 2 factorial. Hopefully you know in some feel for why it is what it is. So then this is plus, and then we'll do the nth derivative at A, x minus A cubed over to the n over n factorial. Now what we're doing is finding the Taylor series at some other place. If I took e to the x and centered it at 0, I'm doing all my approximations starting there. So if I did a linear approximation, the minute I get too far away, I get off, don't I? Yes. It makes me centered here at A. So if I wanted to find e to the 9.1, for instance, for the Taylor polynomial, I would center it at e to the 9th, because that's pretty close. If I try to do e to the x centered at 0, I need a whole lot of terms to get it to converge, not just a few. Where this will converge very quickly, 9.1, if I do the work to center it at 9. Converges everywhere, but I need many terms to do e to the 9.1 if I center it here. Because you can see as I get away from it, I start getting errors. Okay, so that's the point of that. So this was at A. So f of A is e to the A. Oh, I should have put that in here. So f of A is e to the A. Eric, what's f prime of A? E to the A. What's f? I like e to the x, because guess what? It's easy. Okay, so it's e to the A plus f prime, f prime of A, which is e to the A, then it's x minus A, plus it's e to the A, x minus A squared over 2 factorial. That's all it is. What's the nth derivative? E to the A, and they are not going to give you e to the x. They're going to give you the sign, so you have to figure out what's happening. And it's x minus A to the nth over n factorial. And if you wanted the radius of convergence, you would have to actually do the ratio test on that. Mm-hmm. Yeah. Say it again. This is x minus where you're centering it, A. So it's not centered at 0. Yep. So if this is e to the A. What if A is x is equal to A? What if I'm at the center then? What happens to all these terms? Yep. So e to the A equals e to the A. Yeah. They are if I do e to the A. What if I do e to the A plus 0.1? Then they're not 0. What about e to the x at 0? What about, let's look at e to the x at 0. What's e to the x at 0? E to the x at 0 is 1 plus 0 plus 0 squared over 2. And we knew it was 1, right? Add x, add x equals 0. Okay, guys? I know, I'm trying to explain it, but these guys aren't paying any attention. Okay. You guys, at x equals 0, you centered it here, so your Taylor polynomial is this. Well, it better be equal to the value there. Remember, that was our first condition, was that our T of A had to equal F of A. But, so where would I do this? Where would I use this one? Maybe I want e to the 0.1. Not e to the 0. So e to the 0.1 is 0 plus 0.1 plus 0.1 squared over 2 factorial plus 0.1 cubed over 3 factorial. I don't know how many terms you need to get it to be pretty close to e to the 0.1. And it's how your calculators work, Sect. The calculator doesn't have a table of values for e to the 0.1. It uses Taylor polynomials. Well, take a look at the AP questions. You've got a whole packet of them. Yeah, go look at the AP questions. We'll do them. I'm just giving you the concept. Okay. It's that ugly looking thing. It's that thing. So if you do a plus 0.1, then this is going to be 0.1 squared. And that's e to the 0.1. That's all. What about the sine function? Now notice I want the Maclaurin series. Zach, do you know what that is?
I know, I do.
Do we need to do it? Well, you guys should be able to do this. I need f of x. What's f prime of x? Guess what you did? You did the cosine. What's the derivative of sine? Let's do a second derivative. Now, you guys tell me why this is hard to just use that formula. Plus, you could have read your book. Negative cosine of x. And the fourth derivative gets me back to the sine. So you can see what's going to happen to the sine, S-I-G-N. So this is how I organize it. What's f of 0? The sine of 0, which is 0. What's f prime of 0? Cosine of 0, which is 1. What's f double prime of 0, which is minus sine of 0? It's 0. What's f triple prime of 0? Negative cosine of 0, which is negative 1. That's your alternating sine. And it's x minus 0. So what is the sine of x? I'm not going to write the 0 term. It's 1x minus x squared over what? 2 factorial. Plus x to the, oops, it's not x squared, it's x cubed. Thank you. Now, I was going to catch that. How was I going to catch that? Sine is an odd function. Plus x to the 5th over 5 factorial. Minus x to the 7th over 7 factorial. And it's minus 1 to the what? Now, this is 1, 2, depends on where you start. And then it's x to the 2n plus 1 over 2n plus 1 factorial. Okay, you have to memorize this. You have to know e to the x, sine of x, cosine of x, the geometric one. Those 4. For the exam, yes, you need to know by Friday. No. Oh, I want to do the 2 different methods. Yeah. Now, you did the cosine in your lab. Okay, Zach? You did the cosine in your lab. How does the cosine relate to the sine? Okay, sine of x is odd. Okay, Grant, how does the cosine of x relate to the sine of x? That's true, but there's a relationship between cosine. It's the derivative of the sine of x. Guys, you had 3 days of chit chat. Guys, yeah, but you said you didn't get it. You didn't understand it. So if you didn't, that's why I'm going through it. Okay, Michael, how do you can find the cosine the way you did in your lab. I'm not going to do that with derivatives. It's the derivative of the sine. So what's the derivative of this power function? 1 minus 3x squared over 3 factorial plus 5x to the 4th over 5 factorial and minus 1, and then it's 2n plus 1 x to the 2n. Yes, yes. 2n plus 1 factor. I'm not going to reduce yet. So this is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. These cancel. This 2n plus 1 will cancel with that. Oops, forgot my n. Pardon? 1 minus plus, yeah, it's minus 1 to the n. And then the 2n plus 1's go, x to the 2n over 2n factorial. So that was a different way of finding cosine. I use derivatives. If I use the derivative of the sine. If I do the derivatives using the Taylor polynomial, I'll get the same answer. So when you do the problems on the exam, if you can find a faster way to do the problems, then you should do that. You have all the test questions. Well, all the AP questions are online. Pardon? The cosine is the derivative of the sine, so I just took the derivative. I had better get the same answer no matter how I do it. Guys, do you need to sit someplace else? Okay. Are we done with this one? So you need to and you need to do it right now, write down these. See if you can do that. If you did that, that's great. I've never seen it. I know, but I've never seen it on the exam. That doesn't mean anything. Okay, we ready to go on the next one? Not yet? Ask me questions. Yeah. I don't understand that, but that's good. Okay, ready? How about that one? It's so easy. How are you going to do it? What's the cosine of x? Okay, can you tell me what this is? Grant, quick. 1 minus, no, just the cosine. Remember, this is an even function. That's how I remember them. Okay, what's x cosine x then? What are you going to do? Multiply by x. Well, you guys, you could have figured this out. You guys are really smart. In your job, I don't necessarily care about the textbook problems. If you need practice with them, great. I would do the AP problems. Oh, thank you. Because that's even, that's odd. I forgot to add that one in. Grant, why don't you put some effort in here? Where's your pink sheet? Is it a sign? No. But what they're going to do is on the exam, okay, guys, you may end up running into one of these special power series in the middle of a problem and then have to apply something you know. Like if they ask you for the cosine of pi over 6, you see the power series. I don't want to put pi over 6 in there. I know what the cosine of pi over 6 is. So you say, oh, it's the cosine function. I just have to find the cosine of pi over 6. So it's easy. How about e to the minus x squared? Yeah. Guys, I can't hear her. It's okay if you don't care, but I need it quiet so I can hear. I got to be careful with that. I believe the answer is no, because when you take the derivative, you're going to have pi's in it. It has to be just, well, that's the hard part. When can you just do that? Let's do the next one. And you can always check it with a derivative, by doing derivatives. What's e to the x? Okay, but you better be able to give me the nth one. Okay, what's e to the minus x squared then? 1 minus x squared plus x to the 4th over 2 factorial, right? Plus minus x to the 6th over 3 factorial plus dot, dot, dot. And this is going to be a minus 1 to the n. Probably I'll double check it because it might be n plus 1. I don't know. But it's x to the 2n over n factorial. So how do you find the antiderivative? Just integrate this. That's easy. Can you, those of you with CAS calculators, can you integrate that? Integrate it term by term. What's the antiderivative of 1? X. Duncan. Oh, I just put in x squared. I actually put in minus x squared. Minus x squared to the n. So I factor that out. I put this in. And this is a negative 1. So you have to distribute the exponents. It goes to that one, and it goes to that one. And that's x to the 2n. It's a good question. Well, the n's don't get integrated, just the x's. This is x cubed over 3 plus x to the 5th over 5 times 2 factorial minus x to the 7th over 7 times 3 factorial. X, now this is going to go 2n plus 1. Yeah, you guys could have done this last week. You have more work to do now because we still have the test coming up. So what if you wanted to integrate it from 0 to 1? Right. So you put in 1. Now that might be a geometric series you get. This might be something you can do. Okay, guys? And this is 1 over 5 times 2 is 10. They might ask you a certain number of terms. Do not give more terms than they ask. Never give more than they ask. Okay, so this is 1. Please pick that up before you leave. Okay, etc. This is example 3. And then you're going to subtract and you're going to put the zeros. What happens when I put the zeros in? 0. They might ask this because it's an alternating series. They might ask you to do it to a certain number of decimal places. They might ask you only for the first 3 terms. What's true about the error? The error is less than this term. Do you remember that from before break? Yes, the error from an alternating series. Now, I would do it that way rather than using the Lagrange error bound. How about example 4? Grant, why don't you come up and do example 4 for us? No, you don't get that. Just do it. That. Okay, I've seen this on the exam. There's two ways to do this. Two ways to do this. You can do L'Hopital. We barely know L'Hopital. First off, you put 0 in, what do you get? Now, if this is free response, you guys, this is multiple choice. But if this were free response, you must write in 0 over 0. You may not go to L'Hopital until you have shown to the reader that it is L'Hopital's rule does apply, and you have to have 0 over 0 for it to apply. They don't even care if you do this, Grant. So what do you get when I do this? What's the derivative of e to the x? E to the x minus 1 over 2x. Derivative. Now, if I put in 0, what do I get? 0 over 0. So guess what? You have to show that. Everybody better be good about that because I hate to see you get it wrong because you didn't. Well, guess what? We got to do L'Hopital's rule again. Hi. What's the derivative of this one? It's probably one of my students. They were coming today. Over what? 2. And so that's equal to 1/2. But there's another way to do this. I can use the series, and they may ask you to do the series. The series? Oh, L'Hopital is nice, but it doesn't always work. We did. Okay, let's put in the series. It's the limit as x goes to 0, because the series is nice. What is e to the x as a series? 1 plus x squared over 2 plus x cubed over 3 factorial. Who cares about the rest of it? Minus 1 minus x over x squared. I've seen this problem. This is just like some of the free response questions. What happens to the 1s and what happens to the x's? They cancel. Okay, so now I'm left with, I don't want purple, the limit as x goes to 0, but if you just take care and just do it slowly, you'll be fine. It's x squared over 2 plus x cubed over 3 factorial plus a whole bunch of terms with x's in it, and then it's divided by x squared. What happens when I divide it? No, it isn't. When I go into x squared into this one, I'm left with what? 1/2. And all of the other terms, when I divide this, will still have an x in it. Next one's going to be x squared over 4 factorial. And when I take the limit and let x go to 0, I get 1/2. But I've seen this where there is no other way to do this. You have to use the series. You might as well be aware of that. Now, you should have Taylor polynomial problems. I printed them out for you. I would start with 2012 and go backwards. I think it was a purple sheet. Yes, it is. It's right here. Plus, I have some other ones. I have 2009. Why don't I give these out, too? Yeah, you got the purple sheets a while ago. Long time ago. But then I'll give you the yellow sheets. I think I gave this to you as well.